An electric vehicle starts from rest and accelerates at a rate of 2.0 meters per second squared in a straight line until it reaches a speed of 20 meters per second. The vehicle then slows at a constant rate of 1.0 meters per second squared until it stops.
Part A asks how much time elapses from start to stop, and Part B asks how far the vehicle travels from start to stop. Let's picture what is happening first. The motion does not happen all at once in the same way. The vehicle speeds up, reaches a top speed of 20 meters per second, and then slows down until it comes to rest. Because the acceleration is different in these two stages, we must treat the motion as two separate parts, and then combine the results. We start with the first stage, where the vehicle accelerates from rest to 20 meters per second. Here, the initial velocity is 0, the final velocity is 20 meters per second, and the acceleration is 2.0 meters per second squared. To find the time for this stage, we use the equation v equals u plus at. Substituting the values, we get 20 equals 0 plus 2 times t. Solving for t gives t equals 10 seconds, so it takes 10 seconds to speed up. Now, we move to the second stage, where the vehicle slows down from 20 meters per second to 0. The initial velocity is 20 meters per second. The final velocity is 0, and the acceleration is negative 1.0 meters per second squared, because the vehicle is slowing down. Using the same equation, v equals u plus at, we substitute and get 0 equals 20 minus 1 times t. Solving for t gives t equals 20 seconds. So it takes 20 seconds to come to a stop. To answer part A, we add the times from both stages. 10 seconds plus 20 seconds gives a total time of 30 seconds from start to stop. Now let's find the total distance traveled for part B. Again, we handle each stage separately and then add the distances. With constant acceleration, a very intuitive way to find distance is to use average velocity times time. When acceleration is constant, the average velocity is simply the initial velocity plus the final velocity divided by 2. For the first stage, the initial velocity is 0 and the final velocity is 20 meters per second. The average velocity is therefore 0 plus 20 divided by 2, which is 10 meters per second. The time for this stage is 10 seconds. Distance equals average velocity times time. So the distance traveled while speeding up is 10 times 10, which is 100 meters. For the second stage, the initial velocity is 20 meters per second, and the final velocity is 0. The average velocity is again 10 meters per second. The time for this stage is 20 seconds. Multiplying average velocity by time gives 10 times 20, which is 200 meters. Finally, we add the distances from both stages. 100 meters plus 200 meters gives a total distance of 300 meters. So the final answers are: the total time from start to stop is 30 seconds, and the total distance traveled is 300 meters.